We're going to talk about third-party code, third-party libraries, the risks, give you a little bit of what's going on, and then we're going to also offer up some potential solutions for you. So my name's Jake. I'm the CISO at Risk-Based Security. Been doing vulnerability intelligence for a long time. Run OSVDB and Data Loss DB, if you know that. And I'm joined by Kimberly.
Hi, I'm Kimberly Price, and I'm director of a red team for BugCrowd. And before this, I worked in security incident response at BlackBerry and data analytics and threat intelligence at Microsoft.
We were going to add a crazy cat picture poster on there, but she didn't like that.
Yeah. Every Friday on Twitter, it's Cat Friday. So
if you're into cats, you can follow her. All right, so what are we here to talk about? And really, for most organizations and most people, it's an unknown. It's a big question mark still. Most people don't understand sort of what this third-party library stuff really means. And in many cases, people don't really understand how it's impacting them at their organization, right? So trying to get your head wrapped around the issue is part of the biggest problem with this whole third-party risk stuff, okay? So what happens when you don't think you understand what's going on? Well, you turn to sort of metrics or some sort of what's going on out there in the world, right? And so the security space, we love our metrics, right? We're always seeing vendor reports coming out, things coming out, bunch of stuff on vulnerability statistics. In Black Hat in 2013, Steve Christie and Brian Martin were here and did a talk on vulnerability stats and pretty much why they suck. So if you're interested in understanding that sort of thing, can you keep hearing me or is it going out? All right. You can go check this out, right? So regardless of them complaining about statistics, what are we going to do? We're going to give you some statistics. So get ready, right? So this is some iChart data from OSVDB about vulnerabilities over time. And so what you want to look at here and what we're trying to describe basically is what is going on in terms of the number of vulnerabilities. I'm not trying to say that's the right metric or anything like that. But what you can see from this is we are not seeing a slowdown in vulnerabilities reported and discovered. So we may be investing in security, we may be talking about it all the time and the government and this and that, but we're still seeing a whole bunch of crap code coming out, right? And in fact, in 2013, from the OSVD stats, you're seeing over 13,000 vulnerabilities disclosed, right? If you look at sort of the breakdown of them, you're seeing a ton of cross-site scripting, a ton of SQL injection. Vulnerabilities that should have been eradicated 10 years ago are still most prevalent out there. So it's pretty frightening, right? And there's a whole blind spot here that this isn't even talking about software as a service or any of those types of things. Can you hear me now? All right. Okay, so with that being said, there's a blind spot, lots of vulnerabilities still coming out, okay? All right. Now, I want to play a little game with you, and these lights are actually brutal, so it's really hard to see everyone out there. But let's play a game. How many vulnerabilities, in terms of count, did you think there were in OpenSSL for the issue known as Heartbleed? So the Heartbleed vulnerability, how many would you count that as? What do you think? One. Let's not overthink this, right? One vulnerability. Do we agree? Yes? I can barely see most of you, so let me hear you. Do you agree it's one vulnerability? Yes. The answer is yes, one vulnerability in our world, right? So, Secunia, a company that does vulnerability intelligence, they put out a report, it's a pretty nice report. They counted that there were over 15,000 vulnerabilities. And so again, when you look at some of these reports, you need to understand the methodology behind it. So most people would agree Heartbleed was one vulnerability. When you look in the methodology of this report and what you start to see, they counted it 210 times, okay? We still believe it's one vulnerability, but yes, 210 times it was counted in this report. So you have to look at these reports and understand how things are being counted, what's going on, before you sort of run off and sort of make decisions on what's going on, okay? So I wouldn't say that Heartbleed was 210 times worthy to scream about it, but it was a big deal, right? Heartbleed was a big deal. It got a lot of attention, and people started to understand what was going on. A fancy logo can go a long way. We all know that. But it really was the point where it started to get people to understand that one vulnerability can go across multiple things. And when you're seeing reports on news media and all this sort of stuff, it's something that gets people's attention. So it started to raise the awareness of this thing called third-party libraries. People get mad at this slide, but in estimates, it was around 100 plus vendors plus impacted by Heartbleed, as well as over 600,000 servers on the internet that were impacted by the Heartbleed vulnerability, right? You can get mad at this all you want. The point is, lots of vulnerabilities, lots of impact all over the place here. One vulnerability impacting lots of vendors and lots of code that was unexpected. So here's just a small sample of some products that we're listing up here, about 68 of them or so before we got tired of typing them up. And most people say, well, wait a second, you know, the only people using OpenSSL and things like that are maybe startups or small companies that can't afford. This isn't enterprise stuff, right? But then what you start to see is that very large companies are in fact using OpenSSL and other libraries in their code. And in fact, I can't tell you the number of times we've had conversations where people will say, we don't use any third-party libraries at our company, and then they list off all the vendors that are using third-party libraries, right? So people are still trying to get their heads wrapped around it. After Heartbleed, we had Freak. Everyone remember this? It might have got more attention if it was maybe Super Freak. But at the same point, we're starting to see more and more of these vulns. We then have a Scary Poodle, right? So Scary Poodle's going to come attack your network. And then a bunch of logs, so Logjam, right? So again, we're continuing to see sort of the naming of vulnerabilities, logos, all those sorts of things. All right, I want to play another game. How many vulnerabilities do you think there have been in OpenSSL since Heartbleed? And please, for the love of God, don't use the Securing accounting method. How many vulnerabilities do you think? Let me hear you. 7? 50? No one else?
We're hearing 5 over here.
5, okay. All right, well, so here's the ugly eye chart of all the vulnerabilities in OpenSSL since Heartbleed. Once the little animation comes in there all the way at the bottom, you'll see that's all the way back there, April of 2014 when Heartbleed was there. And so 52, so whoever said 50, you're pretty close. Come find me for a beverage later. 52 new vulnerabilities. If you're a person that likes CVSS, right, there was some in there that had the CVS score of 10, on average 6.78. And if you think about it, Heartbleed itself was rated as a 5, right? So one could argue that lots of vulnerabilities since then and lots that were sort of more critical. Now, if you hate CVSS, version 2, and maybe even version 3 that's coming, let's look at a different metric here, right? So let's look at, here we go, we're looking at 9 of these 52 had an exploit publicly available or some type of POC, okay? So now we're talking about a little bit of a different way to look at it. And if you look further, 14 of those actually had a private exploit, all right? So just a different way to look at it. So many people could look at this and say, while we didn't see all these on the news, and they didn't all have fancy logos and whatnot, they could be more impactful than even the ones that we saw. All right, so here's a scary ghost, and for all the researchers in the room, remember, pick your name and your logo carefully, or one like that might get assigned to you. But the point of this is just to show that we're beating up on OpenSSL for good reason, but at the same time, this is much more than this, right? This is the GNU library Ghost. So it's not just OpenSSL, that this stuff's out there. And in fact, I'm not sure what's going on with us these days, but we named it Ghost. But if you even go back to 2005, there was an IE vuln out there that we called Ghost. So let's try not to recycle the same names. We can get a little more creative, right? So, all right. What this is showing to us is this whole concept of systemic risk. Things are interconnected, right? And if you think about it in terms of the insurance world, this is really well known. This is one hurricane event that comes up and causes massive problems, right? One event causing lots of problems. And you start to see this in third-party code library usage, right? One vulnerability affecting all of that. And that's why it's such a big concern in many cases. So I'm not here to talk complete trash about third-party library usage, whether it's open or closed source, nothing of that nature. There are great things, right? Developers and companies are under pressure to deliver better, faster, cheaper, all three. And libraries, they're great. They do a lot of great things. But at the same time, you need to understand that this efficiency and the goodness that comes with it comes potentially at this cost. And so in many cases, it's not just the one vuln across loads of products or organizations. In the research that we're doing, we're seeing that one application can have hundreds and hundreds of third-party libraries as part of it. And in many cases, organizations are not treating that third-party code accordingly. There's a company called Black Duck out there that categorizes open source components and looks at it. So we reached out to them to say, you know, how much of this stuff is out here, right? We've named a couple vulnerabilities. Kimberly's going to go over some vulnerabilities in some libraries. But Black Duck basically said they're tracking over 1 million open source projects. We believe that means with versions, right? Different versions of it across 6,000 sites. In our world, we think the number is probably around 1,500 to 2,500 libraries that are routinely used, but this is still an area that's being discovered. Third-party libraries pop up all over the place. And so again, part of it is really understanding what you're using. And the other metric that they shared with us was interesting is that 30% of the Forbes Global 2000 enterprise code is actually open source. So it's something that is out there and something that's growing. All right, we'll talk some library data.
I would love to talk some library data. So I'm going to not stand behind the podium because I'm not tall. Before we start talking about data, I want to be clear. First off, we're not advising, as Jake said, to not use third-party libraries. We're hoping to talk to you about the information you should have on the libraries that are being used to ensure that you're planning your resources, whether they're technical or personnel resources or time scheduling for secure development, and not just the post-release incident response piece of it, but even during design and development. So all of the data that we're presenting today is from public sources. I wanted you to be able to go back to your office, and if you needed to do a proof of concept to demonstrate to your leadership team why you need funding to implement some tools or a threat intelligence feed, you could do that. It's not super scalable long term, but you could at least get a start and show them why this is useful. So I pulled the data from public sources, but as you can see on the slide, FFmpeg in CVE details has 191 vulnerabilities tracked. If you look in VulnDB, which is a paid threat intelligence feed, there's over 1,000. Math is hard, but it's not that hard. And so why is that? Why is there a difference? FFmpeg will flat out tell you they silently patch vulnerabilities they don't assign CVEs to. So if you're looking at a public CVE database, you're only getting the CVEs. When you're considering a threat intelligence library, make sure that the vendor you're considering giving money to is doing a thorough security assessment of that library and documenting the silent fixes for you. So that said, this is all public data. I'm not going to be able to tell you about the ghost fixes. Let's start with OpenSSL. And I'm going to talk a little bit, Jake talked about the spread of this, but I want to start with them because it sets the stage for the other libraries we're going to talk about. Who uses it? Gmail, Tor, Yahoo, Tumblr, LastPass. LastPass is kind of a problem if they're holding all of your passwords. Pinterest, VMware, Dell, Dropbox, BlackBerry, all these companies. I got tired of pulling logos, so we've also got F-Secure, IBM, Novell, Red Hat, McAfee, F5, Cisco, Fortinet. Every time there is an OpenSSL vulnerability, all of these vendors have to patch. And sometimes they have to patch in multiple products. And I've actually seen products use multiple iterations of the same library, where you've got two feature teams that both use the library, but they didn't talk to each other, so they're not dynamically linking it, and they're both running their own versions, and sometimes they're running different versions. So this is a whole lot of patching for OpenSSL, and we all felt that pain during Heartbleed. But as Jake mentioned, if you patched Heartbleed and you didn't patch again until Freak or some other major named event, you probably missed patching some vulnerabilities. So next step is FreeType. FreeType is a font rendering library, and this is super useful. I don't really recommend that you decide to start from scratch and write a font rendering library if you've never done it before. It's really nice to be able to use something that someone else has been working on for years and years and is used in Android, iOS, Chrome, FreeBSD. GhostScript is in printers all over the world. So you've basically got some things nested in there. It is also in OS X. WebKit. What's interesting is WebKit is another third-party library, so you have libraries nested in libraries. So anything that uses WebKit may be vulnerable when FreeType has a vulnerability. We've got Gentoo, Oracle, BlackBerry, Fedora, PlayStation, so we're starting to get into gaming devices, Opera for Wii, multiple video games. And so I'm not gonna lie, it was kind of fun, like investigatively tracking down where all these libraries are, because it's in the American Girl doll game. I did not see that coming. Those dolls are a little creepy. Maybe they're going to hack you. But the bigger issue is FreeType, being a font rendering library, is used in a lot of places. So CVE 2011-0226 didn't have a catchy name, but it was a CVSS 9.3, and this vulnerability was used in Jailbreak Me for the iPhone in 2011. And if this were a locally exploitable vulnerability, the jailbreak would primarily be a terms of use violation, a EULA violation, but it was remotely exploitable. So there was a missing parameter check that allowed a malicious font program to move a stack pointer. And now all of a sudden, if you're using FreeType to render your email and your browser, just reading an email could own your device. So this is why libraries really matter, because now you have to wait. You can't patch FreeType. You have to wait for the vendor to patch it for you. libpng, we've tracked this to over 130 applications, including Google, Apple, Adobe, Microsoft, VMware, BlackBerry, Linux. It's everywhere. And the reason it's everywhere is compatibility. You want to be able to view PNGs on everything. So it's even in things like PowerPoint, Visio. And again, it's in WebKit. So again, you've got some nested libraries going on there. Solaris, VMware Server, countless applications. Tomcat. Now, we haven't talked about Tomcat a whole lot when we've given this presentation in the past. Tomcat is used in SAP, VMware, Nokia, EMC. You're starting to see a very different type of application. These are much more enterprise applications. You're not seeing Pinterest up there, but SAP, that's your accounting and payroll. That matters a whole heck of a lot. So we've got that all over the place. And you're also starting to see the same vendor logos over and over and over. And that's going to be important in a minute for the next slide. Flash Player. Flash Player's in Microsoft and Oracle and IE and Chrome and Firefox and BlackBerry and WordPress and even Apple. You can point to the fact that Apple isn't shipping Flash Player, but if you've got users in your enterprise with Macs, have they installed Flash Player? How are you getting that fixed? So Apple is still issuing patches for Flash Player on Mac, so that still has to get updated as well. And then a few other things. It was actually used in some Samsung smart televisions as well. Don't know if Samsung's patching that or not, but. And then Java. Java wins hands down on the vulnerability spread competition. We shipped it to Mars. It is on the Mars rover. It's in almost every, I jokingly thought it would be easier to list the places it wasn't used. It's not used in towels, for example. It is in nearly everything. And so jumping ahead, let's look at the actual breakdown of numbers. This is from January 1st, 2007 until June 30th, 2015. And when a library wasn't around that long, I'll note it in the data. So OpenSSL across this 8.5 years has had 90 vulnerabilities. They're averaging 10 to 11 a year. But they're only releasing 3 times a year. So from a patch management perspective, you're only going to have to update that library on average 3 times a year. Their average CVSS score is 5.49 if you're into CVSS. But as Jake mentioned earlier, Heartbleed was only a 5, so sometimes really bad stuff comes in small packages. FreeType had 50 vulnerabilities, about 2 releases a year, and you can see their CVSS score is rather a bit higher at 7.43. libpng, dropping down even further, only 28 vulnerabilities over 8.5 years, 6.65 in the CVSS, 2 to 3 updates a year. Tomcat, jumping back up to 100, 5 updates a year on average, CVSS of 4.72 though. And here's where you get into weird things with your data. Tomcat will CVE really low CVSS score vulnerabilities. They'll issue a CVE on a 2.4. And a lot of vendors will only CVSS in the 5 and above range. So again, Data isn't perfect, but this is what's publicly available. You'll see 100 vulnerabilities, but overall the impact is much lower. Flash players, 2009 to present. They have 522 vulnerabilities in that time, but they have a very consistent release schedule about once a month. And their average CVSS score is 8.96. And then Java still beats Flash Player with 539. They only update quarterly though. So when you get a Java update, think about it from the enterprise. You get an update, you don't just roll that out. You do some app compat testing. You make sure you're not going to break anything. Software vendors have to do the same thing. So if they get a Java update that has 52 vulnerabilities in it, that's a lot of testing before they can integrate and implement it. But that's 8.5 years worth of data. How bad is it today? Let's overlay 2015, just vuln for vuln. OpenSSL has 29 out of those 90 just in the first 6 months of this year. You drop down to Flash Player, they're having a rough year, 135 in the first 6 months of this year. That's 25% of their total 8.5 year total load of vulnerabilities. Java, 58 so far this year. This is not to say that FreeType is more secure than Flash Player. Adobe has a robust, mature security team that does pen testing. They bring in consultants. They run bug bounties. They're actively looking for vulnerabilities. I don't know what I don't know about FreeType. So again, when you're looking at data, this is not telling you what's more secure. It's telling you how to plan your resources if you're using any of these libraries. So that's the hasty generalization. Don't assume something is less secure because it has a lot of vulnerabilities in it. So you're saying, well, wait a minute, you just told me how many vulnerabilities things have. I thought we weren't supposed to just like count vulnerabilities and say it's insecure. Should you be using count of vulnerabilities? Should you be looking at frequency of updates, average severity of vulnerabilities? Maybe the most important thing is there a POC or exploit? Yes. There is no one measure to rule them all. It's all data you use to make conscious risk decisions. And what we're going to talk to you a little bit more about, this is all laying the groundwork for what Jake's about to talk to you about around window of opportunity. So how long has the vulnerability been known for, and is that a factor for you to think about as well?
Thank you.
You're very welcome.
All right, so we've tried to sort of lay the land for you of what this third-party library stuff is, give you a little feel for where it is, which seems to be everywhere, and sort of what's going on. But in terms of what you can do at your organization, right now it sort of feels like it's a little helpless, it seems, right? So we want to talk to you a little bit about this thing called VTEM. And it's a number of years of research finally coming together. This is the first time we're talking about it publicly. And so it stands for Vulnerability Timeline and Exposure Metrics. And so basically what it is, it's a framework that's trying to define and provide guidance for vulnerability timeline tracking, okay? So if you think about a vulnerability, there's a life cycle associated with it, right? From the time a vulnerability is introduced into a code base, to it's discovered, to it gets fixed, and all this sort of stuff. There's all these dates and time points, right? So this framework's trying to define what those dates are, and then some calculations that maybe can give you some metrics, right? And those metrics can allow you in doing better vendor evaluation, better product evaluation, and then ultimately at the end, understand the exposure that your organization is really facing to these issues, okay? So we're gonna run through this a little bit. But you probably sit there and say, do I really care about this stuff, right? So we're hoping that you should care for a few reasons. And again, the metrics should help you evaluate and select vendors to work with that actually care about security, right? So we keep tracking data left and right, nothing looks like it's getting better. 10 years from now, if we give the same talk, are we going to say the same crap? Vulns keep coming, breaches keep happening. Nothing seems to be sort of moving it in the right direction. Well, if we actually start to have some metrics that can better evaluate our vendors, maybe that can force vendors to actually start producing secure products, right? So instead of working on that next feature, maybe they'll start working on actually securing their products, since we know there's going to be some evaluation against them. If you choose to work with vendors and use your wallet or your pocketbook and put it with vendors that care about security, can start to force things down that path, right? Market forces prevail. maybe instead of sort of the software liability arguments that keep coming up. And then secondly, it's actually going to truly help you understand your organization's exposure and what vendors and what products are really sort of the biggest offenders in your organization. What are you dealing with? Okay? So what do we want to accomplish with V10? So we want to define the timeline and exposure terminology and try to make it consistent usage, right? So for organizations, for researchers that are discovering vulnerabilities, as well as software vendors. And even more so, define expectations for certs, for the software vendors and researchers on the dates and the data that we're looking for in their vulnerability research and their disclosure or coordination processes. So again, it's a framework to assist your organization with understanding your own time of exposure, identifying those vendors and products that are contributing to this exposure, allow you then to create a scorecard where you can monitor performance of these vendors and products, and assist you more than anything of maybe that upfront, select the right vendors and products to work with. Understand that total cost of ownership of making these decisions. So dates. So there are 9 dates right now that are part of the V10 framework, but there's already another one being argued that needs to be added into it, which is fine. You know, this is meant to be a living framework, but think about it. So here they're quickly, right? Vulnerability is introduced at some point in time. A vulnerability is discovered at some point in time. A vendor is informed at some point in time about it, and then at some point later they respond, right? Now things get gray in the vulnerability lifecycle. If you actually spend the time to do this, these dates are all over the place. They're not sort of linear straight. I mean, you know, things come out before other things happen, and so it gets a little murky at times. But again, defining the dates that we want to understand, this is what we're doing first. So vendor informed about it. Vendor at some point acknowledges this. Then we're going to get a vendor solution to this situation. Again, another point in time. And then the disclosure of it, right? Okay, now, if a vendor doesn't do what we expect in terms of a solution, maybe there's a third-party solution or a fix that can help it. There's a date for that. Exploit publish date. Again, that could come out well before any of those other ones, but there's a date where the exploit becomes public. And then the final one that helps you with your organization is when do you actually solve this? When is it the solution implemented at your organization? So these are the core dates of the framework right now. So, great, just throwing a bunch of dates at you. What does that actually mean? What does it matter? Let's show you the money, right? Okay, so over the next couple slides, I've just picked one vulnerability to sort of give you a flavor of how this can work. So this is an old school NetScreen vulnerability that I personally have understanding of and know that all the dates for these calculations exist, okay? There are tons of vendors that could have been picked and bad examples and all that sort of stuff of things. We can go into that later. But this is a NetScreen vuln from back in 2002, a long time ago. And so the first metric that V10 provides is one we call vendor response time. And again, the purpose is to demonstrate the response time from a vendor being informed until they actually respond to a researcher. And we're not talking about an automated response. And if you think about the whole full disclosure, ethical this and that, coordinated disclosure stuff, a lot of it is about vendor response time actually responding. So we can do that, right? Those dates that we talked about, we have them. So when was the vendor informed and how long did it take to acknowledge? So looking at this vuln here, you can see they were informed on October 8th, and they acknowledged a little bit later. Great, we have a date, right? 37 days to get a response. And I submit these to you not in good or bad. That comes later on when we start doing more work. But we can see what their response time was on this particular vulnerability. Time to patch. What do we mean by this one? This one means to demonstrate the response time of a vendor from when they were informed to when they provide and publish a working patch for the customers. Again, you can see here, they're informed in October 8th of 2002, and then the solution comes out late November, right? And so simple metrics here that we can basically say 48 days is what it took from the time that they were made aware of it until when they provided a patch. Now, here's where we're going to get a wordsmithing is going to come in, right? So we see time to patch, but there's all these variations to it. So the next one is total time to patch. And what are we trying to say here? Here we're trying to say what is the total amount of time from when the vulnerability was discovered to that patch then becomes available. And so you can see here in this particular case, it's not too much difference because the vulnerability when it was discovered, it was only a couple days later that it went over to the vendor, right? Now, if there are gaps in this, You can understand if researchers are sitting on vulnerabilities, if there's something else. There are two different sort of metrics that you can start to look at to make it actionable for your organization. All right, now we're going to talk about a few that are more specific to what your organization could be, and this is the time of exposure metrics that we've been talking about. So let's assume that all of you work for a company called Evil Corp. We agree? Yeah? So we're all working for Evil Corp. And in this particular case, we're trying to determine when Evil Corp is able to solve this vulnerability. So this metric, time of exposure, is to demonstrate the exposure of the organization is vulnerable from when a fix is published to they implement the solution, right? And so you can see in here, we go through the whole deal. We're basically saying that Evil Corp could only solve this the next quarterly maintenance window, which happened to be on Valentine's Day the following year. And so what's their total exposure for time of exposure here? 81 days, okay? Now we're going to do, again, another slight variation, and we're going to say total time of exposure. And this is to demonstrate the time of exposure in an organization from when the issue was discovered until it was fully implemented, right? And so we can see here that that metric's quite a bit different now, right? Now it's 131 days. And so you're starting to see the differences on this, okay? That can help you to make those decisions about what's going on with this particular vulnerability. Now looking at it as just one vulnerability, you get to see all the metrics, and it's great, and it may be something that you say, what does that mean to me? But when you start looking on the whole for lots of vulnerabilities to a particular product, and then those particular products to a vendor, it starts to paint a picture of how is that product being handled and how is the vendor response time being there. So it starts to help you understand a larger picture, right? And then over time, we believe we're going to start to be able to see what averages look like. All right, so here's another one just to show you a little bit of a different situation, because some of this stuff can be a little bit challenging. So this is the Seagate NAS remote code execution from late last year. And so this one was tricky with the vendor response time because things got a little crazy. And I think this is up for a Pony Award for worst vendor response, right?
Lamest vendor response this afternoon in Ponies.
Lamest vendor response is this one, right? And so when you say lamest, what are the sort of qualifications for that? Well, if we can start using the V10 framework to put in there some response data and some metrics, maybe that also helps, right? So the vendor actually responded quickly, if you will, but it was ridiculously ineffective, right? And it created this 2.5 sort of month delay. And you're not going to be able to read this, but this is OJ on Twitter who kept sort of going to their support on Twitter, and they kept saying, submit it into support. Here's technical support. And he kept saying over and over, no, I'm trying to submit a vulnerability. I'm trying to do it securely. And it was just bad, right? And so then eventually over LinkedIn, he gets the right security contact, and they were able to acknowledge it. But again, we're seeing a sort of a problem with that, right? So you can see sort of the metrics down below. Again, it was October of 2014 when it was discovered. A few days later is when he started trying to make the contact, and then there's new vendor contact, and then ultimately it was acknowledged in the next year in January. So at that point in time, we're talking about 83 days to actually get some sort of proper response from the vendor, okay? And again, just for the sake of it, we started showing you some of the calculations. Again, assuming Evil Corp, patching 90 days later, you can see sort of the amount of time. And what you can start to see is that when communication through vulnerability disclosure and contacting vendors and those sorts of things happen, it starts putting your organization more at risk. And so therefore, you want to work with vendors that have this down, that actually when you contact them and say, hey, I have an issue, you don't get spun around for 2.5 months because it's putting you at having more exposure for you than you need to. But wait, there's a lot more, right? So a report came out here recently from Symantec, and it said, did you know it takes 59 days on average to create and publish patches for 0 days? Does anyone know what the heck that means? Well, if you actually look in the report a little bit more, what you find is they say the average time taken between publication and patch. And so many would say, well, is that what we're talking about with 0 day? Right now, I don't know who agrees, and again, I can't see you all, but I feel like 0 day term has been so bastardized that it's used sort of all the time, right? So if you think about old school O day or 0 day, in many cases it was used to define some sort of issue that the vendor didn't know about or it wasn't publicly disclosed. That was typically what O day is. But now you're hearing all sorts of things where maybe something goes out public, right, but it doesn't have a fix with it, and now we're calling those O days. So it's getting sort of confusing on what the heck's going on, but you can see, again, these are just some random things pulled from Wikipedia and the like, where you can see, again, a zero-day vulnerability refers to a hole at the software vendor unknown to the vendor, right? So the whole point here is, can we finally, with the VTEM framework, define what the hell O-Day is, right? We do have some dates now that we can talk about. And maybe what we're trying to describe with zero-day or O-Day, there's a couple flavors to them depending on what we're getting at. So again, a couple dates that are important here, right? The vendor informed date, the disclosure date. And again, if you're one of those folks that argues it's actually about solution date, well, that date's there as well, right? But again, if we want to say, hey, 0 days when a vendor doesn't know about it, or it hasn't been publicly described, on this chart here, you can see from those 2 dates, that's what we're calling 0 day. And then anything after that is not really 0 day, right? So look, we can argue this stuff to death, but it would be really nice to finally sort of, with some dates, describe what we're talking about so we can communicate consistently. All right, more to come with the framework, right? So exploit availability, this is a big one, right? Because again, the life cycle changes differently. And when you talk about prioritization of vulnerabilities, which there's been some great talks that Kimberly and some others have done as well, exploit availability in many cases can mean a hell of a lot more than a sort of CVSS or things of that nature, right? Time of exploit exposure, what are you dealing with there? And then there's all these other variations potentially to look at, right? So we've been saying total time to patch, but is that really when it was, should it be something different? Should it be when it was introduced? So we've been talking about some additional metrics, and maybe we'll call them, true type or true total time, where it's talking about when it was first introduced in the code base, right? We've seen some bugs that have come out that have been sitting in plain sight for 20 years. It was introduced here, hasn't been discovered here. So that it can give you some more clarity on who's looking at these things, what's going on. Third-party solutions, are they getting involved? And then a whole bunch about the roll-up calculations. How can we take, one on a whole doesn't give you a whole lot of information, it gives you a little bit, but when you start to roll it up and understand about that product or the vendor, it gives you a lot. And then of course we're going to argue the names and the calculations absolutely to death on this stuff. Get something out there in a framework that we can start using. All right, so I want to talk a little bit more about sort of that exposure analysis, and in order to do it, I'm going to talk about some SCADA things, okay? So, Schneider Electric. It's again, this particular vulnerability is something that near and dear. We know all the dates, and so that's why it was selected. It's a little bit of an odd, confusing one, but want to share this with you so you understand how this stuff happens. So this was actually found by Carson Iram. He's the chief research officer at my company, so we know all the gory details on this one. But he found a remote code issue in a serial driver, which you could say is a library and or component for them, right? Because this one vulnerability was across 11 of their products. So this was in early 2013 in January, reported to ICS CERT at the time. They were the ones that then started the liaison with the company Schneider, right? And again, that's one of the dates we're probably going to add in here, is because there could be a delay time from when an intermediary, when you as the researcher reported to sort of a coordination vendor or a bug bounty vendor, there may be a delay, and we want to make sure we understand why that is. So that may be another date coming here soon. So a little bit later, not too long, 20 days or so, Schneider confirms the vulnerability, and then a little bit after that, actually a month or so after that, they then published a security notification with no patch, and they just sent something out to their customers just saying, hey, there's a vulnerability, but there's nothing you can do about it, right? ICS CERT and Karsten were going back and forth, but didn't really do anything else. Nothing else was published from ICS CERT. At that point in April, again, from when the vulnerability was found earlier the year, details were then published in the VulnDB and some other things, some other vulnerability databases were picking it up. All right, great. We can calculate all sorts of metrics in there, the VTEM stuff there, all the dates are there that we need to do that. But what I want to focus on is a couple things. So it wasn't until April 1st, 2014, that's when ICS then provided a warning. Until that time, from the time it was discovered, there was no CVE to sign. Anyone relying on NVD was in the dark, right? And even when that information then came out from ICS CERT, it was wrong. They were saying it was a local issue, which it wasn't, right? It was a remote issue, and therefore the CVS scores were wrong, et cetera. And what was also really weird was we say no patch until that time, right? And what was really strange about it, there was one developed. Schneider actually developed a patch. They just chose not to release it to customers. They basically said, patch is there, but we're not going to include that until we do a roll-up into another version that we're going to release. So again, you start to think about this. There may be a fix for the issue, but your vendor's not even letting you get to it. So again, reminder, this vulnerability was discovered January 5th, 2013. ICS CERT, April Fool's Day, imagine that, in 2014, releases it. And so when we start to look at some of our VTEM calculations, you're saying here the total time to patch is 451 days. Okay? Now, why does this matter? Because VTEM gives these metrics of time to patch and total time to patch. And so they're not saying, hey, the product's great or it's bad, but they're again talking about the vendor capabilities, the response capabilities to these issues. Unfortunately, right now, not that many date information is being provided, and we're not sure why, right? Why does an ICS CERT provide this stuff? We should be asking that. We should be wanting these things. And so with everything, we see that not all vulnerabilities are equal, and so it takes a different amount of time. But in general, we're seeing that people believe 180 days is probably reasonable, and many people believe it should be 90 or less. We did a quick calculation using about a 2-year period for some SCADA vulnerabilities. 25 vulnerabilities were analyzed from 14 different vendors. On average, the total time to patch was about 155 days, with the worst being the one that Carson discovered at 451. Why is this important? Because when you talk to sort of any energy or SCADA people, they always come up and say things like, well, look, there's this NERC requirement that we have to do all our patches in 30 days. So yeah, we're really good at that patching stuff. 30 days, that's all our exposure is. But the reality is when you look at these things, your time of exposure or total time of exposure is based heavily on your vendors and their responsiveness and how they're handling things. So this gives you just a different way to look at things and what you're dealing with.
All right. I only got a few minutes, so I'm going to go fast. We started giving this talk. We had a 25-minute talk slot last year here at Black Hat, and we had a bunch of vendors in the audience who were really interested, asked for copies of our slides. And so, like I said earlier, we were trying to help people use this data in their business and put it to use without being a data scientist. So the vulnerability data is out there, it's public, it's free. If you have a paid vulnerability feed source, awesome. You need spreadsheet software. You really can do this with Excel. Probably a browser would be helpful. I highly recommend it. That is really all you need to do all of the vulnerability analysis and trend analysis that we talked about earlier. So VMware came to the talk, and they've got a pretty mature security response and really security assessment team across the board. And they wanted a copy of the slides. They invited us to come speak at their internal security conference. They were talking a lot with their leadership team about security risk. And they discovered, just like I had discovered when I had been at BlackBerry, your legal team is your friend. Crazy, I know. Your legal team is your friend because they care a lot about third-party compliance. They want to make sure they're clean and true with all the legal agreements. So if a developer just implemented a library and forgot to document it somewhere, your legal team may be able to help you get funding for things that you need to monitor that better, because you can't fix something quickly if you don't know all the places you use it. Going on an Easter egg hunt looking for where you've implemented OpenSSL when there's a heartbleed happening, you need to know exactly where it is. And so they, like I said, had a mature incident response team. What they did was they added proactive evaluation and rating and approval of third-party libraries. So now if a development team wants to use a library, they have essentially a dictionary or a playbook of here are the things that are approved for use in these situations. Here are the things that are approved for use in other situations. Here are the things that are not approved for use because we're not willing to take on the security risk. And as I mentioned, the legal team gave them funding to implement a source code scanning tool that would tell them what libraries were in use where, what vulnerability loads came with it, so that they could really quickly, when that new advisory came out, go figure out exactly where they had to patch. So, they did a lot of really great stuff to move the ball downfield in managing their third-party library risk, in terms of partnering with dev teams, active testing. You can't just test your native code. If you're taking on a third-party library, it's yours to have and to hold now. So you need to start contributing back and actually testing that library as well. upstreaming vulnerabilities to that library vendor to make sure that that's staying secure because you're using it. Quick action and response. We started giving this talk last year focused on security response, helping security response teams talk to their development teams about patching libraries. But the reality is, where are vulnerabilities created? Design and implementation of your security development lifecycle. Where are they identified? Verification, and usually in your response phase after you've released the product and your external security research community does you a solid, helps you find out all those vulnerabilities you didn't know you had. Unless you use third-party libraries, because then vulnerabilities are being identified all the time. And so you could design your application using library version 1.4.6 in design phase, but by the time you get to release, they're up to 1.4.9. Have you kept up with it? Have you been updating your library during development and changing your design assumptions to go with the new library because you've got new vulnerability fixes? So that's the first call to action. Don't think of library management as a response issue. It's all throughout SDL. Second thing, prioritization matters. If you have 150 vulnerabilities open with a CVSS 7.5 and above, some are internally found, some are externally reported from finders or security researchers, as they're more commonly referred to. Some are in third-party libraries. Your inbound vulnerabilities, let's say they're 15 dev tasks a week. Do you even know how many security dev tasks you fix a week? What do you fix first? Highest CVSS score? First in, first out? Last in, last out? Externally known? Issues with exploit presence? You need a clear prioritization model because intelligent prioritization reduces your risk in those libraries. And so all of the data we've given you today, the work we're doing to try to create VTEM, not just on a vulnerability by vulnerability basis, and we gave you vulnerability specific examples today, but that's where we're starting. We need more data, we need more dialogue about how to build this so that we can take it up to the vendor level and say, on the whole, looking at the body of vulnerabilities that this vendor was responsible for, here's what their time of exposure is, here's what their responsiveness is. This is a mature, healthy organization, or they're kind of languishing. I just like The Incredibles, and it's a good. So, proactively manage your risk. Understand what third-party libraries you're using and where. Treat those libraries with as much diligence as your native code. Use data. Go talk to your leadership team about, hey, that library we just adopted, they had this many vulnerabilities last year. That's X% more vulnerabilities than we had last year with our current dev team. How are we going to do that? How are we going to fix that? Do we need more resources? Do we need to plan our schedules differently? Have that conversation to make sure you're spending resources on the most important things. And work with vendors who care about security. Like I said, it's not just about vulnerability load. It's about responsiveness. It's about they clearly make security a priority through pen testing, through their security advisories. You know what a secure organization culture looks like. Look for that in your vendors. And try to collect more data on the date metrics. And the more data we can get, the better we can measure these things. And please, please, please get in touch with us if you would like to work with us on VTEM, or if you have feedback, both about this talk or about VTEM, we would love to hear it. So, and I just got the 0 sign, so I think we're do we have any question time, or are we done? Done. All righty, come ask us questions out in the hall.
Thank you.